Hello everyone, it's me, Mr. Tardy. I am out for today, so I decided to record this presentation. Okay, so this is going to be Glencoe's Introduction to Physical Science 2005, Chapter 10, Section 2, Acceleration. Now, in our last chapter, we just talked about velocity, speed, distance, and displacement. Okay, oh, well, I want to go over that in a quick review. So, displacement and distance are two things. Distance is the amount of distance traveled overall, while displacement is how far are you from your original starting point. Okay? Now, when you take your distance and you apply it with time, the distance over time, we get speed. Remember that? So your distance traveled divided by the time it took you to travel it. So if someone travels 500 meters in 25 seconds, then they are at a speed, writing this down, of 20 meters per second. Okay? Anyone have any questions on this so far? Now, speed is different from velocity. Okay? There we go. So if you want to take your velocity, velocity is a speed with a direction. So the 20 meters per second is not a velocity, it's just a speed. But 20 meters per second left or south or eastward, however you want to put it. Now that we have a direction in application, this is a velocity. Okay? So that covers up a little bit of review that I wanted to bring up with you guys, okay? So, distance and displacement is motion over time. Distance is the total amount you traveled, while displacement is how far are you from your starting point. Speed is your distance over time, and velocity is your speed in a direction. Okay? So, oh, there we go. Acceleration and motion. And last section, we mentioned that velocity is time over direction. Acceleration is the change in velocity over a period of time. So a change in acceleration, it can occur from speeding up, slowing down, or changing direction. So if you have a car, oh, not what I meant to click. If you have a car and the car gets faster, then it is accelerating. If you have a car and the car goes slower, then it is also accelerating. And if you have a car and the car is changing directions, that is also a form of acceleration, making the speed go up, making the speed go down, or changing the direction is all a way to change your velocity. So velocity is the change in speed over time plus direction. Okay? Speed up, slow down, changing direction. Okay. If an object is speeding up, then its acceleration is increasing, and it is positive acceleration. These are points you want to write down. These are what's in your notes. Is it one to one directly? No, but your notes are fairly close to what you're supposed to be seeing. Okay, as long as you're paying attention and listening to me, you will be getting what you need for your notes. So if it's speeding up, then it is increasing. This is considered positive acceleration. If the acceleration is slowing down, it is decreasing. It's considered negative. Positive acceleration is going in the direction of its current motion. So if you think about the car is going forward, and then you give it more oomph to have it go forward faster, that's going to make it accelerate positively. Conversely, if the car is going forward, but there's a force causing it to slow down, the acceleration is going in the opposite direction. Okay? Now remember, changing direction is also acceleration. So the acceleration could be the same speed, but its direction is changing. This is a form of acceleration. When you go around the corners in the hallway, right? So let me draw it out. You got the hallway. Here's the water fountain. Here is the library, right? And you're walking to my class. You're probably not changing speed, okay? What's going to occur is you're going to change direction. You're walking at the same pace, but the direction changes. So this is another form of acceleration. Does this make sense? Okay. Now, if we think about acceleration, it's how fast there is an increase or decrease in speed. The formula is A, acceleration equals velocity over time. A equals V divided by T. Velocity divided by time. So the SI unit is going to be meters per second squared. If you remember, speed is meters per second. And then we're dividing it at by seconds again, correct? So another way to rewrite this is going to be meters per second squared. You want to write it out in full. It is meters per second squared. Okay. If we have an acceleration of 10 meters per second squared, then every single second, our speed is increasing by 10 meters per second. So 0 to 10 meters per second, to 20 meters per second, to 30 meters per second. So let's think about it like this. We've got Kanan. Kanan is at 0 miles per hour. And when he accelerates, he's accelerating at a rate of 15 meters per second squared. What's going to be Kanan's speed at 4 seconds? So, bless me. We have Kanan, and Kanan is in his car. And right now he's stationary. He's not moving. But he accelerates at 15 meters per second squared, right? So at the 0 second, when he starts out, he is at 0. But at the 1st second, he's at 15 meters per second. At the 2nd second, he is at 30 meters per second. At the 3rd second, he's at 45 meters per second. And at the 4th second, he's at 60 meters per second. So that means after 4 seconds, Kanan is traveling at a velocity of 60 meters per second. Does that make sense to you guys? Okay. To calculate acceleration, we use a formula. Average acceleration, we take our final speed, we subtract it by our starting speed, and then we divide it by how long it takes. The formula is written right here in the form A equals S2 minus S1 divided by T. S2 minus S1 divided by T. Now, there is another way to write this. Some people don't like to use the 2 and the 1. So instead, they call it SF for final speed minus SI for initial speed divided by T for time. So S2 and SF are the same thing, and they represent the final speed. S1 or SI stands for initial, which is just a fancy way of starting or saying starting speed. Okay? T, as always, is time. Oh, going to that one by accident. I'm going to move you here so I don't keep on clicking it. So S2 minus S1 over T, or SF minus SI over T. Now, acceleration can be positive, negative, or 0. It's positive if you speed up here. If you're speeding up, it is positive. If you're slowing down, it is negative. And if you're staying the same speed, you're not changing at all, then it is 0. So consider Brooklyn. Brooklyn was running at 15 meters per second. But after 10 seconds, she was at 5 meters per second. What was her acceleration? So let's calculate this out. Brooklyn had a final speed of 5 meters per second. Brooklyn had I'm just going to put SF here. Brooklyn had a starting speed of 15 meters per second. So I'm going to say S. And I know it's subtraction because that's what my formula says. And the time, it says Brooklyn took 10 seconds in order for this change to happen, right? So I'm going to put down 10. We can find that 5 minus 15 is going to be negative 10. And we divide it by 10. Put it into a calculator if you absolutely need to. You know where my calculators are. But 10 and negative 10, and you're dividing. Okay, give us -1. That means Brooklyn's acceleration was -1 meters per second squared. The P is the same way as writing dash, okay? Those both mean per. And you can see here that my answer matches that. 5 minus 15 divided by 10, -10 divided by 10, -1 meters per second squared. Okay. Graphing acceleration. So if you remember, we can make a graph for velocity using distance and time. We can make a graph for acceleration as well. Ooh. So we used distance and time to make a speed graph. And it would look something like this. Okay. Now, if we want an acceleration graph, which we will often abbreviate acceleration as ACEL, we need to use speed or velocity. We're going to make it simple and just use speed and time. And again, you're going to gain same parts. There's going to be ups, there's going to be downs, there's going to be some ups, some horizontals, some ups, some downs, some ups, some downs, some more horizontals, some downs, etc., etc. These are all what parts of a graph can look like. So, speed is on the vertical axis, while time is on the horizontal. As a reminder, this is vertical. This is up and down. Horizontal is on the horizon, the left and the right. Okay? If the line is going up, like it is right here, it's going up, we call that object speeding up. So we can see here, this line is speeding up because the line is going up. Here, we can see that it is slowing down because the line is going down. And if it's flat, that means that it is not speeding up, it is not slowing down, it's going at a constant speed. Okay? So our vertical axis is speed, our horizontal axis is time. Line going up means it's speeding up. The line going down means it's slowing down. The horizontal means that it is constant speed. It's not stopped moving. It's constant. It's just not changing. It's staying at 60 miles per hour. It is staying at 10 meters per second. It's still moving, still going forward, but it is not stopped. Okay? I need that to be clear and crucial. Okay. If you have any questions so far, do feel free to ask your stub. He'll try to help you to the best of his capabilities. Let's take a look at the final set slides. I wanted to take us some practice. So, the first question is, what is the difference between speed, velocity, and acceleration? I'll give you 5 seconds. Feel free to pause it if you want to give and try and answer. So we got 5, 4, 3, 2, 1. Okay. So speed is distance over time. Velocity is the speed plus a direction. And acceleration is the change in velocity over time. So we can see that right here. Distance over time, speed plus a direction, velocity over time. They want us to calculate the acceleration of a runner if they went from 0 meters a second to 3 meters a second in 12 seconds. So, we have to ask, what was our starting? Oh, oh, good googly moogly. Oh, I'm zoom. Whoa, whoa. Sorry about that, guys. Okay, so let's see. What was our starting time? Well, we started at 0 meters a second and went to 3 meters a second. So our start, our initial time, our initial speed, SI, is 0. Our final speed, our SF, is 3. If you remember our formula, it is SF minus SI over T. So we're going to do 3 minus 0 over, oh, wait. What was the time? Well, I'm going to go back and check what the question was asking. 12 seconds. So we know that our time, T, is 12. Now I can do 3 minus 0, which gives me a 3 divided by 12. And check your calculators if you need to. Your answer is not 4. It's going to be 1 over 4. And when we put that as a decimal, that's going to be 0.25 meters per second squared. Okay? If it's 1 over 4, that's going to be a decimal. If it's 4 over 1, it's just going to be 4. The positioning matters. What's on top and what's on bottom. Okay? So we had our formula, SF minus SI over T. We had our calculation, 3 minus 0 over 12. And we have our answer, 0.25 meters per second squared. Are we clear on that? All right. Final question I want to talk about. We have an object. Okay, could be any object. Could be a bowling ball, could be a shoe, could be me, right? Now, this object, I'm gonna make it a shoe. That's a weird looking shoe. Now, this object was dropped off of a building. And gravity, which is the force that pulls stuff to Earth, and why it makes it round, Aiden, is going at an acceleration rate of 9.8 meters per second squared. So we want to find out what's its speed going to be after 2 seconds. So at 0 seconds, because it was not dropped, it's just dropped, it's going at a rate of 0 meters per second. We dig that? Does that make sense? At 1 second, then the speed is going to be 9.8 meters per second. And at 2 seconds, then it's going to be another copy. So let's see, 9.8 plus 9.8. Okay, 886, add the 1. 9, 1, 10, 9, 1, and oh, don't forget my decimal. 19.6 meters per second. So this is the final speed of the object when I'm at 2 seconds. Does this make sense? So for the calculation portion, I want you to put the counting 0, 1, 2, 0, 9.8, 19.6. And then for your answer is going to be 19.6. Does this make sense for a practice? I hope so. Now, when I'm back, I ideally will be able to go over this you and briefly, and we'll have very few questions. I do plan on giving you a day to work on this. If you have any questions, do feel free to ask. Hope you're being good for the sub, because I am going to have them write some notes, okay? So, if you have any questions, feel free to email me, but no promises that I will get back to that. You guys have a wonderful day, and bye bye.